Right now, something invisible is hitting your body, and it never, ever stops. It's radiation and charged matter fired off the sun, crossing the void between us in only a few days. Most of it, your planet swats away without you noticing. But every few generations, the sun throws something so violent it has already knocked out power grids, and stars just like ours have thrown things 1,000 times worse. We're climbing the sun's arsenal from mildest to most apocalyptic, and by the end, you'll know exactly how close we've already come to the edge. It starts with the sun's baseline mood, the solar wind, a non-stop stream of particles it has been exhaling for billions of years. That wind is actually plasma, protons and electrons torn straight off the sun's outer atmosphere. It's blowing on every planet in the solar system, all day, every day, with 0 days off. Earth's magnetic field acts like an invisible riot shield, catching most of it before it ever touches you. Mars never got a shield like that. This same wind spent billions of years peeling its atmosphere into space. That's the price of an unprotected planet, the calmest weather in the solar system, and it still strips worlds bare. So even on a quiet day, the sun is already armed. This is just it breathing. Now the sun exhales harder. A solar flare is a sudden eruption of radiation blasting off its surface. In minutes, it can release more energy than humanity has generated across its entire history. That energy travels as light, which means it moves at the single fastest speed physics allows. So we get zero warning. By the time you can see a flare, it has already hit you. The strongest ones, called X-class flares, can blind radio communication across an entire side of the planet. Airlines reroute polar flights. Ham radio operators go quiet. Somewhere, a satellite engineer starts sweating. And a flare, as violent as it sounds, is still just light. The sun hasn't thrown anything at you yet. That's next. And unlike light, this part actually has mass. Brace for the part of the sun's arsenal that actually leaves the surface and comes straight at you. A coronal mass ejection is the sun ripping off a piece of itself and throwing it at you. A cloud of magnetized plasma weighing billions of tons. Unlike a flare's light, this is actual matter, so it's slower. It can take 1 to 3 days to arrive. That delay is the only warning window we ever get before the sky turns hostile. When it reaches Earth, it doesn't glance off. It slams into our magnetic field and compresses the whole thing like a fist hitting a bubble. A direct hit can slam more raw energy into our planet's field than almost anything we've ever built could match. Not every CME is aimed at us. Space is big, and the sun doesn't exactly aim. But when one is aimed right at Earth, everything downstream of that hit starts to break. First, the compass needles wobble. Then the compressed field starts dumping its stolen energy straight into our atmosphere at the poles. And that's where this gets its most famous side effect. The sky itself starts to glow. That glow has a name, a geomagnetic storm, and its calling card is the aurora. Charged particles funnel down Earth's magnetic field lines toward the poles and crash into the atmosphere. This collision lights the sky in green and red. It's literally radiation glowing hard enough to see from the ground. It's beautiful. It's also a live readout of how hard our planet's shield is currently working. Aurora equals just a pretty light show. It's radiation slamming your atmosphere hard enough to glow. During a strong enough storm, that light creeps down to latitudes that almost never see it, a sign the strain is spreading. Meanwhile, the Van Allen belts, 2 donut-shaped bands of trapped radiation wrapped around Earth, swell with extra particles. Satellites drag through a puffed-up atmosphere and lose altitude. GPS coordinates drift by meters. Power grids start to feel it in their wires. None of this is exotic. Weak storms like this happen constantly. Background noise in the sun's ongoing war. It's the strong ones that turn a light show into a warning shot. Solar wind, flares, CMEs, geomagnetic storms. Here's the part that changes everything. All 4 hit Earth simultaneously once and nearly broke the modern world. That happened before satellites, before power grids, before the internet even existed. September 1859, one of the most powerful solar eruptions ever recorded blasts off the sun, and Earth is standing right in its path. It's called the Carrington Event. named for the astronomer who watched it happen, and cautiously suspected it was tied to what came next. A day later, the storm arrives and Earth's telegraph network, humanity's entire long-distance communication system, goes haywire. Wires sparked, operators got shocked at their own machines, some telegraph offices reportedly caught fire. Some lines kept sending messages after operators disconnected their batteries entirely. The storm itself was now powering the network. The aurora that night was seen as far south as the Caribbean, supposedly bright enough that people could read a newspaper by it. It's still the strongest geomagnetic storm ever measured, and in 1859, the only vulnerable technology on Earth was a few thousand miles of copper wire. Now count what runs on wires today: the power grid, satellites, the internet, hospitals, water systems, banks. A direct repeat wouldn't just spark some wires. Modeling suggests it could black out power for weeks across entire regions. Some estimates put the potential damage from a modern Carrington-level storm above $1 trillion, though nobody agrees on the exact number. A CME similar in strength barely missed Earth in 2012, missed by about a week. A week of Earth's orbital position was the only thing standing between us and living through Carrington twice. And here's the part that should really bother you. Carrington wasn't even the theoretical ceiling. It was just the biggest one we happened to be watching for. Because our sun isn't the only star we've been watching. Enter Kepler, a space telescope that stared at thousands of distant stars for years, just watching them for tiny flickers. It wasn't looking for flares at all. It was hunting planets. The flares showed up anyway. And on stars strikingly similar to our sun, same size, same temperature, same age, Kepler caught something our sun has never done. Superflares, eruptions up to 1,000 times stronger than the strongest flare ever recorded from our own sun. On a light curve, it doesn't look dramatic, just a sudden spike in brightness, gone in hours. That spike is a star briefly outshining its own normal output by a massive margin, all at once. If our sun ever did that, a bad flare wouldn't be a bad week. It could be the worst day our species has ever recorded. So has it ever actually happened here? Scientists didn't look in flare records, they looked in trees. Tree rings can trap spikes of radioactive carbon, laid down whenever a massive burst of solar particles slams into the atmosphere. These spikes are called Geomagnetic events, and the biggest one on record hit around the year 774. That single year left more of it in the wood than any other year across 10,000 years of records. Researchers still debate exactly what caused it, but an extreme solar particle event is the leading suspect. If that's what it was, humanity has already lived through something in the Superflare family. We just had no power grid for it to fry. Solar wind, flares, CMEs, storms, Carrington, superflares, it's all one continuous scale, and we've already lived near the top of it. And unlike 774, today a hit like that would strike satellites, grids, and the internet all at once. A modern Superflare-class event isn't a hypothetical monster under the bed. It's a documented possibility we can't yet rule out. So remember the question from the start, whether the star warming your skin right now could actually hurt you. The answer is yes. It already has in 1859, and the tree rings suggest it may have done something far worse, long before anyone was keeping score. The sun that gives us daylight and auroras is the same sun capable, in principle, of a hit 1,000 times worse than anything on record. Every sunrise is a reminder that we live inside the blast radius of a star we don't fully control. Our shield holds, almost all of the time, and that quiet success is the part nobody puts on a postcard. The next Carrington-level storm isn't a question of if, it's a question of whether we'll be ready when it arrives. Next time, we're ranking every way a black hole can kill you, from merely stretching you to erasing you from physics entirely. Subscribe so you don't miss it.